Hi, I have created an AI interviewer. Its name is mockgym.com and I wanted to show everyone how it works. And so I recorded myself a session of giving mock interview for low level design of a parking lot to the AI interviewer. And that's what you are going to see in a few minutes or few seconds, I can say. So my main goal was that each mock interview session should as much as closely resemble the actual interview session. And so I have designed this whole AI interviewer around two things. The first one is that it follows the standard format that is followed basically in almost all product companies, especially the top ones like Microsoft, Amazon, Expedia, you name it. So you will see that during the whole session recording. The second thing around which this AI interviewer is built is the whole content will fit inside a 45 to 60 minutes interview. So all the questions that you will be asked and counter questions, AI bot will try to cover everything within the 45-60 minutes interview. And it will basically, the idea is not to overwhelm you, not to make it overly complicated. You see, and it will try to resemble as much as possible to an actual interview. So watch the session and see how it goes and give Moxim a try. So best of luck. Let's try this question, low level design of a parking lot. Let's start the interview. I'm already using Microsoft Edge, so that's not a problem. We can also use Google Chrome. Don't use Firefox because there are bugs there. Right now it works in voice to text mode, so I will speak and AI interviewer will reply with text. So as soon as the interviewer will start, you will see a welcome message. So here, like we are discussing the low level design of a parking lot ready. So let me select the microphone. Uh, Let me select blue snowball here. So yes, yeah, start speaking. Yes, I am ready. Uh, so what should we discuss? Okay, let me think about the core functionalities. So since I am going to the parking lot, so I must want to park my vehicle. So that should be the first functionality. Yes, since I have parked my vehicle, so I may want to remove my vehicle later, or you can say unpark my vehicle. So that's another functionality. Yeah, there can be other features. I may want to make the payment. So that can be a feature. If I'm using it as an app, then there can be user data management. Uh, Again, there could be notifications and all. There could be some analytics section. So that could be the functionality. So what do you want to discuss basically? I mean, how can anyone lose their vehicle in a parking lot? Okay, so what if someone loses their ticket? So yeah, if someone loses their ticket, then they can mention their mobile number or they can mention their, you can say, vehicle's license plate or vehicle number, and then it could be searched. So your search can be another feature, right? Okay, so for parking our vehicle, let's have some sort of like park vehicle and then what it should take. So can you tell me a bit about the parking lot? Are there like multiple floors or is it like a single floor? Are there like multiple entry and exits? And what kind of vehicles are we going to park? Are there like cars, buses, trucks? So that would help me come up with the exact things. Okay, so they are going to be multiple floors and there will be a 2D grid of rows and columns. So yeah, so for the since only two and four wheelers are there, so we can take a vehicle type and input and let's give it the vehicle number or license plate you can say. And we can also give users mobile number or user ID. Let's just stick with user ID. So once we have parked our vehicle, then it can return the ticket object and the ticket class should contain these fields. There can be other fields, but there should be some sort of a spot ID, the spot at which the vehicle is parked, and other parameters. So like vehicle number can be a parameter, and user ID can be a parameter. We certainly need a ticket ID, and there can be a creation date, the time at which the vehicle was parked. So using that creation date and the spot ID, we can calculate the final amount, payment amount for the user. So tell me if this works. Okay, write the method for removing a vehicle. For removing a vehicle, I guess we can have a method remove vehicle or unpark vehicle. So for unparking, we can have what we can give. We can give the ticket ID itself, and it can return success or failure. Okay, for searching a vehicle where you have lost your ticket, you can give your either vehicle number or mobile number, or if you remember the spot at which the vehicle was parked, then you can give some sort of a spot number, the floor, row, column, whatever. Now the requirement section is over, and now we are in the second section where we have to list down different classes in the system. So okay, let me think about it. Since we want to park our vehicle, so the first simplest class that comes to my mind is the parking spot class. So we have to park in some sort of a spot. So that is the first class that comes to my mind. What do you think? What fields and methods should it have? So let me think about it. Class parking spot. Uh, it can certainly have a spot ID. Apart from having the spot ID, it can also have the vehicle number. So if a vehicle is parked, then this number will be non-blank, and if a vehicle is not parked, then we can make it blank or empty. And then we can also have the vehicle type. We certainly need the vehicle type because we want to park. That's how we will decide what kind of vehicle we will park here. And there can also be an age active because some of the parking spots may be permanently disabled. So we can have this parameter is active. This is all I think we need for the parking spot class for now. Tell me how it works. Yes, we can add each available, but vehicle number will do the job for that too, like I explained. So let me think about other classes. Since the whole parking lot is basically divided in floors, and each floor has many parking spots, rows and columns of parking spots. So I can have a class parking floor, and what it will have is it will have some sort of 2D array of parking spot. And then it will have park and unpark methods, or let's call it remove vehicle methods. So this is how the parking flow should look like. Right now, I don't think it may be useful tracking the number of free spots for each vehicle type. We'll see if it comes to that latter, then we will add that method. Okay, so what class is going to manage parking floors? So yes, we will certainly have a parking lot class, and that class will keep a list of parking floors. or an array of parking floor objects. And this class will have all the methods that we discussed above. So park, remove, and search vehicle. So yeah, I think this class completes the whole loop. This should be the highest level class, sort of the controller class. Alright, so I will want to keep the search functionality separate, so a search manager makes sense. So we can have a class search manager, and it can have two methods. One will be the index. So what it can do is we can index the ticket object at a time, the different fields in it, and we can later search using a query. This query can be spot ID or mobile number or vehicle number. So this is how the search manager will work, and it can keep some sort of map which will act as a cache. So basically string is the field inside the ticket object and the ticket object itself, and let's call it cache. So a simplistic version of it. Okay, so how will we implement the park method? So for the park method, what I am going to do is with the execution will start with the parking lot class, and I will go through each floor. I will call the park method there. If a spot is found on any floor, then I will just select that spot, and then I'm going to index the spot if a spot is found for given vehicle type. Then I'm going to select the spot and index it. So this is how all my parking algorithm is going to work. We don't really need an extra data structure to store the parked or free spots, so we can do it with the data structure that we already have. So for example, on each floor we already have the you can say this 2D array, yeah, of spots. So we can use this 2D array of spots to park the vehicle and remove the vehicle as well. Yes, right. So it is very straightforward, simple, but worst case complexity is like order of n cube. Uh, I mean, n cube means number of floors into number of rows into number of columns. So we can improve that. So we can keep basically a priority queue or list of free spots. So that way the overall parking complexity should decrease. So we will have a map of basically on each floor. We can have a map of vehicle type versus tree set, or we could have kept a priority queue of parking spots, and let's call it free spots. So now if you want to park, just get the vehicle type, and if the tree set has even one element, just remove the first element from the tree set and return it and use it for parking. For removing the vehicle, just get using the spot ID, just get the spot object from this 2D array, free it, and then add it back to the map against the vehicle type. And the overall time complexity now becomes n log n. So it's basically flows into log of rows into columns. So that is better than n cube. Yeah, like I mentioned, we'll get the spots object using the spot id, and then we'll free that, call the free to the that spot object, and we will add the spot object back to this free spots map for the same vehicle type in the tree set. Okay, for searching and indexing, the search manager already has a map. So what we will do is, we will simply in the index method, we'll index the different fields inside the basically ticket object. So, and add it to the cache. So for example, ticket object will have a vehicle number, ticket dot vehicle number, and we'll put it to the cache. Similarly, we'll put spot ID as well, and that can be easily used for searching. When a vehicle is removed, then we can simply remove that ticket object, all three fields, uh, or that is based on the what the interviewer asks. So if they ask to keep the history, then we may not need to remove it, else we can remove it later. Also, the spot id we do not need to remove because it will already be overwritten in case another vehicle is parked at the same spot. So we need to remove the vehicle number, and we can just keep the things as it is. That will also do. The newer values will just overwrite the older values. Yeah, let's think about the different design patterns. Should we move to the next section? Okay, how should I think about using the design patterns here? So if we have like multiple way of parking the objects, then we can maybe we could have used a strategy design pattern here. Right now it is too simple, so I don't think, I think factory may not be there, but yes, we could have used to you could have used a parking spot factory to create, because we need to create a lot of parking spot objects. I'm not able to think of any use case. Can you tell me? One place is when the vehicle is parked, then we can, the search manager can be an observer to the park method, sort of. But since this is only one class, so I will not make it an observer. I will directly call it. Why have the extra complexity? No, right now I do not have any pattern in mind. Now it wants to discuss the different parking strategies. So can you tell me in detail what you exactly want to discuss? Okay, so how will this second parking strategy, especially for EV vehicles, work? Okay, we will initialize the list of spots uh, equipped with electric chargers. These spots will be the part of your existing 3D array. park vehicle should dynamically select one of these strategies. The strategy we already implemented and the parking strategy based on the parking strategy parameter. So can you give me the new method signature for the park vehicle method so that it becomes clear? Okay, got it. Yeah. So now we have an extra parking strategy. So yeah, now we can implement a strategy design pattern here. We can algorithm which we implemented earlier for parking the vehicle. We can call it normal parking algorithm, and the current algorithm for parking EVs, we can call it the EV parking algorithm. So we can have a interface parking strategy, and then what we can do is it will have a park vehicle method, and this interface will be implemented by the class normal parking strategy which we just implemented. Let me just copy it from above. So uh, this will have the basically map of free spots and park method. And then we can have a similar EV parking strategy. Apart from it will keep only free EV spots, and this will have a list of parking spots which are basically spots with EV charger. So yeah, I think this is how this is whole going to work or play out. Yeah, I am maintaining the data structures internally. Yeah, right. Since both the algorithms are working on the same set of parking spots, so there it may be that a parking spot with a charger is already assigned or parked using the normal parking strategy. So that can happen. In that case, I will use the observer design pattern to notify both these parking strategies or any newer parking strategies in case a vehicle is parked using any of the available parking strategies. So we can have some sort of interface parking observer, and it will have some sort of update method, and that can take some sort of spot object. So both the algorithms can implement this update method, and implement this parking observer and give implementation for the update methods. And every time a vehicle is parked, both these observers will be called from the uh, parking lot class. So parking lot class is going to have a list of observers, and it is going to call notify all in case a vehicle is parked or unparked. And notify all is nothing but it will just loop through all the observers and call observer.object update. Now in case a vehicle is parked, then this spot dot vehicle number will be a non-empty, and if it is removed, then the vehicle number will be empty. And based on that parameter, the different strategies can update their internal data structures. Okay, so now what it is doing is it is telling me how I did. So basically it is loading the overall assessment, and it has loaded the final assessment page, and it has told me what I explained, what I didn't explain, and how did I do with the simple implementation and the design patterns part, and basic things what I can improve and all. So this is how the overall interview is going to work. This was all about the low level design of a parking lot and the functionalities that you need to cover. Hopefully you learned something. If you want to try the AI interviewer, you can try it on mockgym.com, and I wish you the best of luck for your interview preparation. Bye for now.